So yeah, my name's Ciaran Byrne. I'm the VP of Product, and yeah, excited to take you through a platform overview. It's intended to be kind of a sneak peek. Probably take about 10 minutes, and we will address some of the many challenges that Helen mentioned. So first, for just go through some of the terminology. So as Helen mentioned, we were covering traditional machine learning models as well as large language models. We also have a concept within the platform of monitors, and monitors are really intended to be easy onboarding. Essentially, upload your data, pick the monitor, and the monitor is really like a use case, and then you will automatically see results. So you have a data quality monitor, data drift, model drift, LLM performance, trust and safety, and so on. So pick the monitor, you get what's called a workbench. Workbench is where you can do deeper analysis, root cause, troubleshooting, and so on. And then you also get dashboards. So the intent is we'll take care of all the pieces behind the scenes for you, the unsupervised machine learning that kicks in, as Helen mentioned, and we will automatically detect anomalies, the relationship between those anomalies, and help you find and pinpoint the issue when they occur. Within the platform, you can easily add a model. The model has metadata where you may define what the model is about, and it has data associated with it, the data sources. Those data sources could come from the likes of Databricks, Snowflake, Prometheus, Elastic, you name it. We can take logs, metrics, and other types of data into the system. And monitors, as I mentioned, are, I'll just go back to this previous slide. Monitors are really, you basically pick your use case. So pick your use case. Use case could be data quality drift, model drift, and so on. So this is an example of a fraud prevention model, and it has basically input is coming from Elastic. So the input could be the data inputs to that fraud model, which could be things like age and so on, and other dimensions. And the output could be, for example, a fraud score. So you may want to detect data drift to see if there's any data drift that's happening on the inputs and any model drift that's actually happening on the output. So again, you associate data with the model, and then you have a monitor. In this case, we actually are looking at the output of that model and checking to see, we're actually checking the score. The score is the fraud score. And we're grouping it by merchant. In this case, the fraud model is working on many different merchants, and it wants to check if any of the merchants are actually seeing drift. So it's looking at it holistically across the various data dimensions. Then the next piece of it's the workbench. As I mentioned, workbench is automatic charts. Each monitor has a chart. This is where you do diagnosis, troubleshooting, look at the timeline, and perform root cause analysis. This is an example of a workbench. Somebody has basically onboarded data quality, and they're looking at things like data integrity. Is there data missing, outliers, some kind of field type mismatch? Or if you have your own custom check, we support regex and many different flexible ways for you to perform integrity checks. This is an example of a consistency check where we have a customer that's checking trading data and to see if there's actually differences between two different data sources, which is very important for them. So this is a workbench. It's distributed by day where you can see the various anomalies that are occurring. This is an example of the model that I shared, which is the fraud detection model. This is an example of data drift has happened here, where we have uploaded a reference model and we're looking at baseline data. So you can see where it's expecting a distribution in these buckets to be, this actual should be here, but the model is actually drifted where the output of the model is actually more in this bucket. So that's an indicator that model drift has occurred. So then the next piece of it is, okay, well, why did that occur? That's where we look at, Helen mentioned earlier about the causal inference and the patterns and technology that's related to that. In this case, we're able to look at changes such as there's a change event that actually happened where the model was actually updated. we're starting to see some data quality issues from that change, which in turn resulted in the model to actually drift. And then you look at, okay, well, how can we remediate that? So another change event was made to actually revert some of these changes and actually broke some of the inputs to the model. So you can see this all happens automatically. There's various monitors in place, but the technology, underlying algorithms are able to detect the relationship between those various anomalies and events that have happened and consolidate them and put them together in this type of timeline view. Next piece, Helen mentioned LLM labs. One thing that we're really excited about is how can we help accelerate the development? How do we help people evaluate various models? In this case, InsightFinder provides the ability for you to actually try these various models within our environment. You can either use your own model or you can use one of the models that we have available for you. So for example, you may want to see how does the performance of like what kind of hallucination do we see in DeepSeek versus Mistral, for example. You can look at the various models, the versions of them, and then you can pick the monitor. This is an example of a trust and safety monitor where people want to look at hallucination, safety, toxicity, bias, for example. You can take that information, send the prompts either to the models in the LLM labs, or actually just use your own model and the outputs from those models. And then we can look at the evaluations. So this is an example of the various evaluations that are being performed. This is showing many of them that are failed. So it's clearly, you can see things like, is it hallucinating? Was the answer relevant? Was there some kind of, is there an attempt at PII leakage? And then you can do a deeper diagnosis to say, okay, well, if the prompt did fail, why did it fail? So we'll give you a readout to say, okay, it's hallucinating. We're detecting a hallucination, and this is why. The example that Helen gave earlier about like it's not able to tell the difference. So we're using various technologies in the back end to help look at the initial response and see if that response is correct or not. So just an example of drilling into the prompt, looking at the evaluation, seeing why it failed. And then the last piece that I'll cover very quickly is dashboards. Again, people are talking about cost, the sensitivities around cost. So you can see things like of the various models, how many prompts are we seeing, how many tokens, input, output, and what's the distribution per day. And if you are using, people might want to know what kind of infrastructure is powering this so we can provide visibility to that as well. So it gives you an idea of the costs that these various models are incurring. And look at anomalies, what kind of evaluations are failing, what's the distribution. Anomalies are more performance-based. In other words, response time, is response time degradation, what's the total response time? And then we'll give you a breakdown where those failed evaluations have occurred. Is it hallucination, relevance, bias, and so on. So it's really your full visibility into the model cost, performance, and health and safety. And that's it.